All right, so in the second part of our lesson for 3.1, we talked about the rules that Euclid's going to give us. And notice we now all of a sudden have all of these little parallel line markings on our drawings. So here's our if-then statement. Let's take a look at it. If a transversal intersects two parallel lines, so keep in mind that's our given. We're given the fact that these lines are parallel, then the corresponding angles are going to be congruent. So Euclid is guaranteeing us that if you see these parallel line markings, then our corresponding, and remember that's the same as our matching, angles are going to be congruent. And when we talk about matching angles, we're talking about angles that are on the same side of the transversal. And we're talking about angles that are in the same position of their lines. See how these are both sitting on top of. So there are four sets of corresponding angles, 1, 2, 3, and 4, with each set of intersecting lines and transversals. All right, so again we have this same given. If a transversal intersects two parallel lines, remember that's our given, then our alternate interior angles are going to be congruent. So our alternate interior angles, remember that tells you where they are, on alternating sides of the transversal. So if this is our transversal, one angle is on this side and the other angle's on this side. And it says they're in the interior. So when we talk about this phrase of interior, that's just this space inside. So our alternate interior angles are going to be congruent. So think about the positions. They're on opposite sides of the transversal. And they are inside of the parallel line system. Our next conversation that Euclid gave us, and again, our given is if the transversal intersects two parallel lines. So we have that same given conversation. I know that the lines are parallel. Then my consecutive interior angles are supplementary. So we have to keep in mind these are the ones that equal 180, our consecutive interior angles. Consecutive means side by side, and interior means it's on the inside. And notice I didn't mark them with the same number of lines because those are not congruent. Those are going to be supplementary. So let's talk about where they are. Consecutive. Do you see how these angles are one after the other? They share this common side. And then they are on the inside. They are interior. And our last set of angles that we need to know about are going to be our alternating exterior angles. Same given. Euclid says if a transversal intersects two parallel lines. So this has to be the true story. And if that's true, then guess what? You're alternating one on one side of the transversal, one on the other. And outside of the line system, they are going to be congruent. All right, so what happens next, and we didn't get a chance to go through this, but let's talk about it now. Given that the measure of angle 1 is equal to something, guess what? We can find the measure of every other angle if we see these lines, these little triangles. So because the lines are parallel, now I can make all these statements. If I know that the measure of angle 1 is 118 degrees, so is the corresponding angle, angle 3. So is the alternating exterior angle, angle 4. And now we need to talk about this angle 2, because this angle is going to be a linear pair with our given, it's going to be supplementary. So when I want to figure out what it's going to be, 180 minus 118 is going to give you your value. So that looks like what, 62? So a 62-degree angle. Did I get that right? 18 plus 2 is 20. 20 plus another 60 is 80, right? So guess what? Once I have this angle here as a linear pair to angle 1, look, now I have my alternating interior angles for number 5, and he's going to have a 62-degree measure. Okay, wrapping up slide 17. When we talk about those measures. Now let's talk about some applications of these conversations. In the diagram of the parking lot, M and N are going to be parallel. So we can go ahead and recognize that these streets, you know, if you want to think about this being a map, M and N are going to be parallel. So if this angle here has a measure of 80, if this line here is my transversal, if here's my transversal, guess what? I'm looking at consecutive interior angles. Consecutive interior angles, which means the measure of angle 1 has got to equal 100 and just a straight 100 degrees, to make sure that we know that those are supplementary. All right, so we're going to dive into a little bit of a sample proof. Use the properties of parallel lines to find the value of x. So we always are going to be looking for, are my lines parallel? Because remember, my rules only apply if this is true. That's where Euclid started every conversation. So if that's true, then I know that those cool angle relationships exist. All right, so I want to find the value of x. So let's go ahead and talk about this. If this is 39 degrees, guess what? The measure of angle 1 is also 39 degrees because they are alternate interior angles. So somebody can say to you, how do you know that's true? Oh, because these are parallel, Euclid told me, if they're parallel, then these are congruent. So I'm going to go ahead and say, hey, look, I have a parallel line, so I know that they're congruent. All right, so I've got the measure of angle 1 plus 7x plus 1 is going to be equal to, so here's a new conversation, that's going to be equal to 180 degrees. How do I know that? Because of the linear pair postulate. And guess what? It also my definition of supplementary. So I did two things in this conversation. I said that one, and I might want to go ahead and say angle 1 and angle, let's go ahead and label this angle 2. And angle 2 are supplementary. How do you know that? Linear pair postulate. Now what else is true? The measure of angle 1 plus that is going to be equal to 180 degrees. That's because I can set it equal to that because I know that they're supplementary. All right, my substitution property equality is going to let me write 39. Substitution property of equality is going to let me do that. And I know, by the way, these are equal to 180. 1 plus 39 is 40. Subtract 40 from each side, and you get 140. So the subtraction property of equality. Therefore, divide each side by 7, and it looks like I have 20. So my job was to find the value of x, and here I go. Therefore, x is equal to 20. Walking our way through that proof, thinking like a geometry student. All right, here comes a good one, and this is what we're going to kind of get into a little bit today when we start talking about having these proofs. What is our given? Our given is that L and M are parallel. So here's our triangles that lets me know that these two lines are parallel. Oh, and guess what? We have two sets of parallel lines. Rock on. Let's get another color marker. because I've got A and B. Now see how they used two triangles to show these parallel lines? So here's this parallel line and here's this parallel line. That's going to be A and B. I need to prove 1 and 5 are congruent. Now here's the deal. 1 and 5 are not connected by any kind of transversal. So my yellow parallel lines are connected by this green one, and my green parallel lines are connected by this yellow one, but nothing connects 1 and 5. So it sounds like I'm going to have to do some transitive property of stuff. And I know I have all congruent symbols, so guess what? I'm going to be using my properties of congruence, not equality. Because remember, I'm proving that 1 and 5 are congruent. And guess what? I get there eventually because here's my task, and I did it by the end. All right, I'm given that those two two sets of lines are parallel. How do I know that 1 and 2 are going to be congruent? Check them out. What are they? They are vertical angles. And that is a theorem that we proved. All right, 2 and 3 are supplementary. What? How do I know that? How do I know 2 and 3 are supplementary? So if I have these two parallel lines and this transversal, guess what? Those are consecutive interior angles theorem. Our consecutive interior angles theorem. IOR. Consecutive interior angles theorem. So they're going to be supplementary. Okay. All right. I see you. Now we have 3 and 4 are supplementary. What? Now look, here's our green lines and here's our yellow transversal, which is going to mean that now in this line system, cover this one up, 3 and 4 are going to be also consecutive interior angles, and the theorem says that they are going to be supplementary. All right, here's a bold move. Hold on, buckle your seatbelts, because guess where we're going next? Now I'm going to say that 2 and 4 are congruent, and that is our congruent supplements theorem. That's the one that says if two angles are supplementary to the same angle, then those two angles are going to be congruent. 2 is supplementary to 3, 3 is supplementary to 4. So guess what? 2 and 4 are going to be congruent. So now I've got 1 and 4 congruent. I'm like, wait, I'm lost. Where did 1 come into play? So let's see, I've got angle 2. Oh, check it out. Do you see the common bridge? 1 is congruent to 2. 2 is congruent to 4. So now I can put together my angle 1 and my angle 4. Do you see how I can do that? Because they both are connected to 2. That is a great example of our transitive property. Careful here, careful, careful, of congruence. We're talking about angles, no measures, no numbers in this entire problem. So we've got to be talking about congruence. All right, now I've got 4 is congruent to 5. All right, guess what? That's back to our vertical angles theorem. All right, so check it out. I now have 1 congruent to 2, 2 congruent to 4, 1 congruent to 4. Now I've got 4 congruent to 5. So here's 4, and he's congruent to 5. And you're like, oh, wait, look where that gets me now. Now I've got 1 congruent to 5, again, by my transitive property of congruence. Rock on. I did it. I made it from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then I was able to connect 1 to 5. How cool is that?